And now I want to spend some time and talk about domains of functions. This is one topic that through the years, as I taught and tutored algebra students, everybody sort of has heard of this word, but a lot of students really don't understand it. It's one of those topics where it can seem bizarre, confusing, but actually it's not really that hard. So through the years, I've developed a sort of a way to teach it that usually when I get finished, students are amazed at how simple it seems after all. So let me go through that, and hopefully when we're done, if you've not understood domains before or it's been a little confusing, hopefully after this it'll be pretty clear. So let me write down the definition that sort of in a average person's language of domain. Start out by saying, when you're given a function, let's just say, right, there's a function, x plus 1. You're asked for the domain of this function. So what they're saying is, what are all the possible values of x? Seems like sort of a strange question. It's almost like, what numbers can I put in this function for x and will everything be okay? In other words, maybe I have to make sure I don't break some math rule or do something that I'm not supposed to do. So you think of this example, well, it's like, well, can I plug in 1 for x? Yeah, 1 plus 1 is 2. Can I plug in 5 for x? Yeah. Can I plug in, how about negative numbers? Can I plug in -2 for x? Yeah. How about fractions? How about decimals? How about square roots? It seems sort of crazy because the idea is I think I can plug in about anything. As a matter of fact, sometimes when I'm teaching about domains, I say, Roy, the better way to approach it is sort of the opposite, and ask yourself, what numbers could I not plug in for x? Is there any number that I could plug in for x where I'm going to have a problem? Like I just said, am I going to break some math rule or violate some principle of math? Now, in this case, I can plug in any number for x and things are fine. Nothing, quote unquote, bad is going to happen. So for this function, you would say the domain is all the real numbers. In other words, x can be any number. Now, sometimes, later on, you'll see that sometimes we like to express domains like interval notation. So the way you express all real numbers as an interval, you basically say you go from -infinity to infinity. That's another way of saying all real numbers. Let's look at a second function. So that seems pretty not too difficult. You sort of wonder, what's the purpose of domains? Because that seems a little strange. Let's look at a second function. How about this one? 5 plus x over x. And we're asked to find the domain of this function. So once again, let's ask that second question. Let's start to think to ourselves, all the numbers I could plug in for x. But the better question is there a number that if I plug it in for x, that I'm going to create a problem, or I'm going to break some math rule? And in this case, there actually is. The first thing I notice is this is a fraction, and I've got an x down here in the denominator and this x up in the numerator. But the main thing I'm looking at is this x in the denominator. Now, hopefully you realize that there's a rule about numbers in the denominator of a fraction. And the rule is hopefully you recall, you can never have 0 in the denominator of a fraction. In math, you cannot try and divide by 0, right? When you have the number in the denominator, in a sense, that's what's it's like. If I have this fraction, 4/2 is like 4 divided by 2. It's 2, right? What happens if I have 4/0? 4 divided by 0? Well, you can't divide by 0. In the world of math, sometimes you see this symbol, which means it's undefined. When you're doing a math problem, and at some point you get to the point where you're ever dividing by 0, you just stop because you're done. You cannot continue on. You cannot ever have a case where you divide by 0. So I look at this function once again. What's my question? Is there some number for x that's going to be a problem? And in this case, yeah. I got to make sure x never equals 0, because if I put in a 0 for x, I've got 5/0, and I can't have that. So from looking at this, I determine x cannot equal 0. Now, how about, is there any other numbers that's a problem? And in this case, no. X can be 1, x can be 2, x can be 10, x can be -5. X can be any other number, and I don't have a problem, except x cannot equal 0. So therefore, what would the domain be? Well, the domain says, well, what can x be? So in a sense, here's how we like to write it. The domain, all real numbers except x equals 0. I'll write that. Except x equals 0. In other words, the domain, what numbers can x be? X can be anything except 0. There's one number that x cannot be. So the domain answers the question, what can x be? Hey, x can be anything except 0. So here's the way I like to approach domain problems. I've sort of started to peel back the onion, and we're going to go into this in more depth. But let me lay out how I approach domain problems, and we'll do some examples. I'll actually give you steps to determine the domain. The first step is, whenever I get a function, it's almost like I don't even have to look at the function. I don't even care what the function is. It's almost like before I even look at the function, I'm going to assume the domain is all real numbers. In other words, from the start, I'm going to assume for this function, x can be anything. There's no numbers that are going to be a problem. That's just what I'm going to assume to start with. So that's always my starting point. Now the second step is, I'm going to look at that function now and ask 2 questions. And here's the good thing about domains. The whole idea of domain is we're looking for numbers that are going to be a problem in a function, numbers that are going to break some math rule. Now, the nice thing is there were only really 2 situations that we have to look out for. There are only 2 cases where we're going to ever have numbers that cause us a problem. So I just have to check both those situations, and after that, then I'm pretty much good to go. So what are the 2 things we're looking for? And I put these in the form of questions. The first one we covered up here, and the question is, are there variables in the denominator? course, this assumes your function is a fraction. Sorry about that. So if your function is a fraction, you go look at the denominator and you say, are there any variables in the denominator? If there are, then we have to check that out. And why do we need to be concerned with variables in the denominator? Because we got to make sure the denominator can never equal 0. If you have variables in your denominator, it's probably possible that certain values for x could cause your denominator to be 0. We can't let that happen. So we have to take this into account. So here's what happens. You're given a function, you're asked to find the domain. I assume the domain is all real numbers. Then I say, are there any variables in the denominator? If the answer is yes, then I have to go in and investigate that. If the answer is no, then I keep going. But now here's the second question. There are only 2 questions, only 2 situations that we have to worry about. The first one is variables in the denominator. The second question is, are there variables under, let me do the sign, right? Right, that's a square root sign. What do you recall is the issue, the thing we have to worry about if we ever deal with square roots? What's the one thing that in the world of math that's impossible? You can't have it. You know what you can't have? You cannot have negative numbers under a square root. It's impossible in math to ever take the square root of negative numbers. Matter of fact, just like having 0 in the denominator, if you're ever working out a problem and all of a sudden you get to the point where you're taking the square root of a negative number, normally you just stop and you say, I can't keep going on. This is not allowed in math. I have to stop. I can't keep going on. So the good thing is, when we're looking for domains, these are the 2 situations we have to look for. So you give it a function, you assume the domain is all real numbers, then you say, do I have any variables in the denominator or do I have any variables under the square root? If I have either one of those or both, then I have to go in and investigate because it's probably going to change the domain. If I don't have either one of those, then I'm done. For instance, what if I go back to this function? So say you're given this function. You're asked for the domain. I'm going to assume the domain is all real numbers. Then I say, do I have any variables in the denominator? Well, no, I do not. This is not even a fraction. There is not a denominator. Then I say, do I have any variables under the square root? Well, there's no square root in this equation. So those are the only 2 questions I have to ask. Since the answer was both no, I'm done. The domain is all real numbers. When I got to this one, I start out assuming the domain is all real numbers, and the first question is, are there any variables in the denominator? And the answer is yes. So I'm going to have to look into that. Let me go and ask the second question. Are there any variables under the square root? No, there are not. But since there are variables in the denominator, I have to go and take that into account. And what I have to do is I have to go in and look at that denominator and decide which numbers are going to cause the denominator to equal 0. And in this case, since it's just x here, I know that x cannot be 0. Therefore, I say my domain is all real numbers except x equals 0, right? Because I started out assuming the domain is all real numbers. And by looking at this denominator, I realize there's a number that is not in the domain that I can't have. Now let's do 2 more functions. How about, grab my notes. Actually, we'll do 3 more. How about we're given this function and we're asked to determine the domain. 4 times the square root of x plus 2. What's the domain? What are the values of x? What can x be? What numbers can x be? All right, first step, I assume the domain is all real numbers. Then I ask 2 questions. I look for 2 things. Are there any variables in the denominator? Well, it's not even a fraction, so the answer to that is no. Second question, are there any variables under the square root? The answer is yes. All right. Since I have the second situation, I have to take into account how that's going to impact the domain. Now here's how I do the problems where you have a variable under the square root. Once again, what's the whole key? What's the problem we can encounter when we have square roots? I'll write it again. No negative numbers under the square root sign. You can't have it. So in a sense, what are we saying? What's the flip side of that? If the numbers can't be negative, that means they have to be positive or 0. So what I'm really saying is I've got to make sure x plus 2 ends up being a positive number or 0. Now the way in math we like to write that, as an inequality. So let me write it and explain it, and hopefully it'll make sense to you. What I'm really saying is, so I take the expression under the square root, and I know that expression has to either be a positive number or 0 to make sure I don't break any math rules. So what am I saying? I'm saying x plus 2 has to be greater than or equal to 0. I've got to make sure that whatever is under the square root is always a positive number or 0. And that's what this inequality says. I'm going to go ahead and solve this inequality. Hopefully you all remember how to do that. It's sort of like solving an equation, right? I want to get x by itself. So if I subtract 2 from both sides, I end up with x greater than or equal to negative 2. This is my solution. This is telling me, hey, these are all the values of x that are okay. As long as the value of x is greater than or equal to negative 2, when I plug it into this function, everything's fine. If we plug in a value that's not in here, then I got a problem. In other words, greater than or equal to 2, how about negative 1? Is negative 1 okay? Yeah, it should be okay. And you plug in negative 1, you get negative 1 plus 2, square root of 1, you're okay. Let's actually do that, just to make sure everybody is clear. Actually, let's do this first. Whenever I have inequalities, here's my advice. It always is a good idea to quickly turn this into a graph this as a number line. It's quick, it's easy, and it's easy to see, and you avoid lots of mistakes. I'm going to graph x greater than or equal to negative 2. So like here's 0, here's negative 2, greater than or equal to, let me draw a bracket. So this I'm saying to my domain. In other words, any number over here should be fine. I shouldn't have a problem. But any number over here is going to be a problem because it's not in my domain. Let's confirm it. So like I said, let's pick a number in my domain. How about negative 1? F of negative 1. I plug it in to my function. Let's just see what happens. Negative 1 plus 2. This is 4 times the square root of 1. It's 4. That's fine. Not a problem. It equals a number. Let's pick a number over here. How about we choose negative 3 over here? So let's say, hey, what is the function when x is negative 3? So it's 4 times the square root of negative 3 plus 2. 4. All right, what have I got here? I'm taking the square root of -1. I can't take the square root of a negative number. So I got a problem here. And this is what I expect, because look at -3 is over here. -3 is not in my domain. And the reason it's not in my domain is because I can't allow x to be -3. So this is how we go about figuring out the cases where we have variable under the square root. So what's the final answer going to be? Actually, I'm going to write it as an interval. It's a little messy, but I'm going to base it off that. I said here, this is going to be my domain. If I write that as an interval, the domain starts when x is -2 and goes all the way to infinity. Let me do a couple more examples. How about have the function 2x over x squared minus 9, and we're asked to find the domain. What's the first step? First step is always assume the domain is all real numbers. And then I'm looking for either variables in the denominator or variables under the square root. What do I have? I have variables under the denominator. So I have to see what the impact of that is. And the main question is, what values of x are going to cause the denominator to equal 0? That's the question I have to answer. Now, some of you might know what this is, but the best thing to do is, and you notice I got this x in the numerator. I don't care about the numerator. You can have whatever you want in the top. I do not care. My only concern is what's in the denominator, what's in the bottom, and I've got to see or figure out what values of x would cause that denominator to be 0. In other words, I'm going to factor this. X squared minus 9 is a difference of squares. It factors into this. Now this is very easy to see. So I'm going to have a problem. I've got these two parentheses multiplied. I'm going to have a problem if either one of those parentheses equals 0. So if I look at that first parenthesis, what value of x is going to cause that first parenthesis to be 0? It's pretty easy to see, right? -3. So I say, you know what? X better not ever equal -3, because if it does, I got a 0 in the denominator. How about the second parenthesis in the denominator? What value of x would cause this second parenthesis to equal 0? And actually, if x was 3, the second parenthesis would be 0. And then I have the 0 in the denominator. So there are actually two numbers that x cannot equal. So therefore, my domain, in this case, I'm going to say all real except x equals plus or minus 3. In other words, a domain is all numbers except plus or minus 3. Domain can be any number except plus or minus 3. Now, there's one more problem. This one has a little twist to it. F of x equals square root of x minus 1 over x squared minus 3x. And we're asked to find the domain. All right, same steps as always. First step, assume the domain is all real numbers. Second step, I'm looking either for variables in the denominator, variables under the square root. Turns out I have both. Look, I've got variables in the denominator, but up here I've got a variable under the square root. So I have both situations. So now I have to figure out how those situations are going to impact the domain. So how do we do this? Well, my advice is you sort of do them one at a time. I'm going to start with the square root part, okay? So whenever we have a variable under the square root, that is, we take whatever is under the square root, and we know that that has to be greater than or equal to 0. So I have x minus 1 greater than or equal to 0. If I solve for x, I would have x greater than or equal to 1. And once again, I always, I'm going to graph these inequalities. It just makes it so much better. So x are equal to 1, so if 0 is here, 1's here. So here's what I've learned. If it's just up to the square root, this is going to be my domain. All values of x greater than or equal to 1. But the problem is, I also have to take into account I have variables in the denominator. So now let's go figure out the impact of that. So let's look at this denominator. Once again, you always have to factor these denominators. I can factor out an x, right? So x squared minus 3x can be written as x times x minus 3. Now, the question I'm asking is, what are the values of x that are going to cause this denominator to be 0? So I have x times the parentheses. I look at this first x. What number could I plug into this x that would make this whole thing 0? Well, obviously, if I plugged in a 0, the whole thing is 0. So therefore, I know that x cannot equal 0. I look at the parenthesis. What value would I plug in for x to make that whole parenthesis equal to 0? Obviously 3. So in looking at the denominator, there are two numbers that are going to cause me a problem, 0 and 3. So I know x cannot equal 0 or 3. So now I've taken the two pieces and sort of solved them separately. I figured out from the square root, if this is my domain, I figured out from the denominator that x can't be 0 or 3. Now, how do I combine these to get an overall domain? Well, what you do is, since I've already made this graph, let's go look at these values of x on this graph. In other words, x equals 0 is right here. I've got to make sure that is not in my domain. But what's interesting, you know what? If I look at the domain of the square root, 0 has already been eliminated. It's like the square root part of it said, hey, 0 is not any good. So I don't have to worry about it. This has already been eliminated from the domain. However, let's look at 3. 3 is like right here. Now here's what's interesting. If it was up to the square root, 3 is perfectly fine. The square root part of it has no problem with x equaling 3. It doesn't care, it's fine. However, though, the denominator says, sorry, x cannot be 3. Because if x is 3, I'm going to have a 0 in the denominator. So what does that mean? Well, it means my domain, well, if I start at 1, all the numbers between 1 and 3 are fine. They work fine both in the square root and the denominator. So those are okay. It's just when you get to 3, you got a problem. So we got a problem with one number, 3. It's almost like we've got this whole domain and I just need to somehow eliminate 3 and everything else is fine. Well, the way I'm going to do that graphically is I'm going to go up to 3. I'm going to stop, right? Put a parenthesis there, which means it does not include the 3. But somehow then I need to sort of jump over this 3 and then keep going. So what you do is you put another parenthesis there. These two parentheses sort of back to back indicate we skip over the number 3 and then we just keep going, which basically says everything from 1 to 3, not including 3, is fine, and everything larger than 3 is fine. So then as a domain, I'm going to write these as intervals. This first interval starts at 1 and it goes to 3 with the parenthesis. But then I also need to include the second interval. So I'm going to union it, and I'm going to pick up at 3 and go to infinity. So this is the domain for this one. Basically, it's saying the domain are all the numbers greater than or equal to 1, except for the number 3. All right, so I hope that's clear. So from now on, whenever you are given some kind of a function or an equation, you're asked to find the domain, hopefully now you realize it's not that hard. And more importantly, you'll understand exactly what the domain is and why we need to figure it out.